Okay, let's continue here. We're going to go through this example. We are going to graph the first 10 terms of the sequence whose explicit formula is this. Explicit formulas are very easy to graph. We've done this before because you can just plug in y equals x squared. You can generate the table of values for the first 10. Okay, the first value, you could get this from your table, but I can plug it in real quick here, is going to be 1 because 1 squared is 1. Second, 4. Third, 9. 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100. Again, you could get this from the table of values or just plug in. If you don't believe me, s of 7, oh, that's 7 squared, that's 49, 749. Okay, on the same set of axes, we're not actually going to graph them yet. We'll graph them in a minute. We're going to talk about this one. This one's a little harder to use. The first term, let's do r sub 1, we know is 1. So my ordered pair would be 1, 1. r sub 2. Let's follow the formula. That is r sub 1 plus 2 times n. Well, what was n? N was 2. Minus 1. Okay, what is r sub 1? r sub 1 is 1 plus 4 minus 1, 5 minus 1 is 4. So r sub 2 is 4. The ordered pair was 2, 4. Okay, let's use this formula again. r sub 3 is r sub 3 minus 1, which is r sub 2, plus 2 times n. What was our n? 3. So 2 times 3 is 6. Minus 1. What is r sub 2? r sub 2 was 4. Plus 2 times 3 is 6. Minus 1. 10 minus 1 is 9. The third term is 9. Hold on 1 second. Okay. Let's continue. r sub 4. r sub 4 equals r sub 3 plus 2 times n. N was 4 here. Minus 1. What was the value of r sub 3? The value of r sub 3 was 9. 9 plus 8 minus 1 is 16. The ordered pair would be 4, 16. I'm just going to do one more. r sub 5 equals r sub 5 minus 1. So that's r sub 4 plus 2 times n. Again, and here is 5 minus 1. The value of r sub 4 was 16. 16 plus 10 minus 1 is 25. 525 would be on our graph. I could continue, but I have a good idea what's going on here. So we'll move to the next page here. Maybe. What do those graphs, if I was to graph those, what is that going to suggest about that sequence of numbers? What they wanted you to get here is you could express them using two different formulas. You could express the sequence in two different ways. Okay, let's talk about Camilla for a second. I don't know, he or she gets a part-time job and saves $75 each week. At the start of the summer, it's her, okay? Her bank account has a balance of $500. Let B sub n be the balance at the start of n. So B sub 1 is 500 because at the start of the first week, she had $500. So B sub 1 is 500. Make a table of values for all the way to 6. So what will B sub 2 be? Oh, why did I put T? Pretend I put a B. B sub 2 is going to be, well, 500. She made $75, so that's 575. B sub 3 will be, add $75. B sub 4, 725. Kenna, mommy's talking to the computer. You have to be quiet. B sub 5 will be 800. And B, oops, forget a 0. B sub 6 is 875. Write a recursive formula for B sub n, okay? Well, what is my first term? B sub 1 is 500. That mystery term is going to be the one before it, plus 75. 4 integers. Well, I guess it depends how long she has a job. But we're just going to say for n greater than or equal to 2. Okay, we could graph this. We could graph all these points. 1, 500, 2, 575. We would do the stat plot. Okay, sorry, this is a nightmare. Anyway, we could plot these points, 1, 500, 2, 575, by using the stat plot that we did for the linear regression. They want to know if the points are collinear. We could look, but you should be able to tell. Yes, they are going to be collinear. This is an initial condition of 500. We have a constant rate of change here, a $75 increase. This should be a constant increase situation. So of course it should be aligned because that rate of change is the same. Okay, come on. Okay, those are notes for your homework, and that's all for today. Kenna, say goodbye, kids.